ready for D, and D you should find just as easy. So we're talking about magnitude of a vector, all right? And magnitude just means the size of it. It means how long is it. So if we have a vector in component form as x, y, then the magnitude is the square root of x squared plus y squared. Okay? Here's the proof for it. If we have some vector, x describes how far it travels horizontally, y describes how far it travels vertically, this here is going to be the magnitude of the vector. And it's a right angle here, it's a right angle triangle, and so we have the magnitude of the vector. What we can do is we can say x squared plus y squared is equal to the magnitude of the vector squared, and then we can square root both sides to get the magnitude of the vector is x squared plus y squared. Okay, very, very simple proof, all right, for the formula for the magnitude of the vector. Okay, so then these two problems here. One is finding the magnitude of this vector. So the magnitude is going to be, now we use two lines. Okay, so if this is vector A, let's define it as A actually, then we're going to say the magnitude of A. All right, we put the two lines on either side of it, that means the size of it, how big it is going to be the square root of the x squared plus the y squared. We do not need to consider negatives because you're going to square it anyway. The direction doesn't matter, we're just concerned with the size. So it's square root of 4 plus 25, it's the square root of 29. Units, that's how long it is. Okay? In the next one, it says find k given this is a unit vector. Now we're going to be using unit vectors a fair bit. A unit vector is a vector with a length of 1 unit. So what that means is the magnitude of this vector equals 1. So we have the square root of 1 on 4 squared plus k squared equals 1. All right, the magnitude of it is 1. We're going to square both sides. So we've got 1 on 16 plus k squared is 1. And then we're solving this for k. We're going to rearrange it. We'll get k squared is 15 on 16. And then k is the square root of 15 on 16, which is root 15 on 4. Now, we are talking about length. We are talking about how long something is. So we do not consider the negative values. All right. Normally, when we square root something, it's plus or minus, but here we're talking specifically about length. So k. Now, excuse me. K is a direction though, so we do need plus or minus. We do need plus or minus because k is a direction. If we're talking about length of a vector, we're not concerned with plus or minus. Here we're talking about, this tells you whether it's moving to the right or left. It could be either. It could be either. It could be moving to the right or to the left. So we need to consider both. So we got the plus or minus there. Sorry about that. Okay, so that's enough to crank out D, 3D. Then we can spend the rest of the lesson on the folio.